Welcome to GKN Aerospace's Masterclass for 2026. So today we're going to be looking at sustainability in aerospace and what the future could look like as a whole. So my name is Maddie. I am a degree apprentice here at GKN Aerospace, and I'm currently in hydrogen systems. So a lot of this directly links to what I work with. And some of my colleagues will also be talking later, and they'll introduce themselves as they come. So what are we going to do today? So there was some pre-work sent out. So if you guys have done that, we'll go through a little bit of those answers. Look at what actually is aerospace engineering and who GKN are. We've then got a mini quiz to get you guys involved. And then we'll talk about emissions and what the future options are. And then some other projects that we do here at GKN. And then we've got a little activity at the end, which you guys will be able to do. And we will answer any questions that you guys want. So if you guys think of questions, you can put them in the chat. And we should have some time at the end to address them. So always keep them coming. No question is a silly question. So the pre-work, if you guys did that, there was a little word search and then just some labels to put on the plane. These are the answers, just some very basic breakdown. And in the word search, they included our company's initials. So GKN does stand for Guess, Keen and Nettlefold, who are our founders. So we'll go on to what is aerospace engineering. So aerospace links to anything that flies. So this includes aeroplanes, rockets, satellites, and there are loads and loads of different companies to build these cool machines to explore the sky and space. Typically, not many people really know who GKN are, but you might have heard of bigger companies like Airbus and Boeing. So GKN is just a supplier to them, but there's loads and loads of different companies out there who work towards the same thing of getting power up in the air. So moving on to what GKN does. So we are a tier 1 supplier, which means that we supply parts to all different areas of aerospace. And we'll break it broken down into 3 sections. So civil, which is like the plane on the top right. So if you're popping over to holiday, we're making parts to go on those planes. We also do work in a bit of defense. So military purposes, so those kind of planes. And we have an engines section. So building more of the power to fly the planes. We also do lots of research and technology. So as you're about to find out, there's lots of developing technologies within aerospace. So making things more efficient and lighter and more sustainable. And our tagline is actually our mission to be the most trusted and sustainable partner in the sky. So as I said before, we are a supplier to those large companies. So we supply parts. So in us becoming more sustainable, we then become a more sustainable partner. On our bottom left is the building where I'm currently based in Bristol. So we have a couple of sites all around the world with over 32 manufacturing locations over all these different countries. So in Europe, the Americas, and in Asia. And our technologies are on board more than 100,000 flights every single day. So usually if you see like a plane in the sky, it's more than likely got some part of a GKN company on there. And we have loads of employees all around the world. But yeah, it is a really good sector to work in. I think it's super interesting. But we are going to jump straight into a mini quiz. So what I will ask the teachers to do, if you don't mind putting answers in the chat, and then it's just like a quick fire A, B, C, or D kind of quiz for you guys to discuss and just put in the chat if that's okay with everyone. And this is just to get you thinking about aerospace and just have fun, really. So how long do you guys think it takes to build a whole plane? I think it's A year, B 6 months, or C 2 years. So the answer to that one is 1 year. So that is quite a long time, but there is so many different parts to a plane that getting them all together in 1 year is actually quite impressive. So a bit more relevant here. So how much do you think of the whole global warming is caused by aviation and aerospace? So I think it's A, 23%, B, 0.5%, C, 4%, or D, 2%. Wow, most of you are right. It's in fact C. So although that might seem like quite a small percent in the whole global warming, it's actually quite a large percentage to have just on aviation and planes. but luckily not as high as 23%. That would be. Okay, next little question is, which of these do you think is longer? A A320 wingspan, which is like a small plane which may take you over to Spain or France on your holidays, or do you think two double-decker buses? Most of you are correct. The wingspan is longer by quite a bit. So an A320 wingspan is about 34 meters, and two buses obviously vary a little bit, but about 10 meters less. So it gives you a bit of visual of how big these planes actually are. We make them. So a bit on materials now. What material out of these do you think is most commonly used in airplanes because it's strong and lightweight? Is it A, wood, B, aluminium, C, iron, or D, plastic? Looks like absolutely everyone has gone with B. And that is good because that is the correct answer. So they're predominantly made of aluminium. About 75 to 80% of a modern aircraft's weight because it is strong, but it is so lightweight. So iron is, although it may be stronger, it's super heavy and you need things obviously to be light if you're trying to put them in the air. So well done. Maybe the first plane's probably made of wood, but aluminium is now the front runner. So I'm now going to hand you over to my colleague Jen, who is going to take over the next couple slides.
Yes, hello everyone. So I'm Jen, a project manager here at GKN Aerospace, and I look at our manufacturing and future skill issues within aerospace industry. So one massive problem in the aerospace industry is CO2 emissions. As we all know, aircraft need fuel to fly, but currently these are fossil fuels or oil, which is found deep, deep underground. And when we burn this oil, it releases CO2 into the air. This ends up trapping heat, leading to climate change, and that's why scientists and engineers are looking for cleaner ways to fly planes. So I do have some scary facts for you all about these emissions. So 90% of aerospace emissions come from the aircraft still flying today. And one long-haul flight can produce more CO2 than the average person emits in a year. So that's only one holiday someone's taking from London to New York. Emissions are not just CO2, so there are other harmful gases also contributing to global warming, and we see really bad pollution on these flight paths as well as around airports. And aviation emissions are the fastest growing sector, so we've more than doubled between 1990 to 2019. And finally, since our first plane was built over 100 years ago, that means the planes today definitely need to change. So, what changes can we make to decarbonize aviation? We have three main options. The first one being electric, so battery powered. And this is really good for regional flights, so flights within the UK. I think our limit for that plane would be to get us to south of France. So we definitely need to develop more battery power. Our second option is hydrogen. And this is best for like Europe trips from here. And we are still developing that and the infrastructure to support hydrogen flight. Thirdly, there is SAF, which stands for Sustainable Aviation Fuels. So this is likely to be the best for midterm solution for medium to long range flights. In 2023, we actually managed to do 100% SAF flight from London to New York. So hopefully we can get to Australia at some point. And now, James, over to you for more detail.
Hey, lovely. Good morning, everyone. My name is James and I work in sustainability here at GKN. Today I'm going to start with talking to you about using electricity as an option for flights in the future, and then later I'll talk to you about some of the projects that we are doing here at GKN. Okay. So to start off, you might have seen that petrol cars that you might drive in are now being switched over to electric cars, and you may think to yourself, why is that? Well, firstly, electric cars don't burn fuel, the fossil fuels that you just learnt about. They use batteries, which are just like big blocks of metal that store energy. And this these batteries are clean energy. They don't release fuel. And you can get the energy from renewable sources like the wind, the sun, or even waves and flowing rivers in stuff like dams. So why don't we apply electricity to planes as well? Well, firstly, planes need a lot of power to run. To put it into perspective, you would need the same amount of energy as 300 electric cars just to get the plane off the ground. Secondly, batteries are really heavy. So like I said, batteries are like big blocks of metal, and that's heavier than the fuel they put in the cars. So again, if we had a battery big enough to fly a plane, the battery would be heavier than the plane itself, and we simply cannot allow that. And finally, last but not least, we cannot charge the plane in the sky. So unlike a car where we can just drive to the petrol station and charge it up, unfortunately we can't do that in the air. So the charge that we have in the plane when we take off is the only thing that we have until we land. Okay, next. So with that being said, what can we do with electricity? Well, we are currently working on something called the eVTOL, which stands for Electrical Vertical Takeoff and Landing. And so what that means is, unlike a plane where you have a long runway, we can just take off vertically upwards, just like a helicopter. And so you might think, why don't we just make electric helicopters? But no, these are different to helicopters for different reasons. For one, they are much quieter than helicopters, and if we're going to use them in urban cities, and we want to reduce the amount of noise that these are producing. Secondly, we are using electricity instead of fuel that helicopters use. Again, cleaner and not producing CO2 that will lead to climate change. Thirdly, they are going to be cheaper to use once they get into service, as the amount of electricity you need will be cheaper than the amount of gas you need to use. And finally, and I think most importantly, is that these will be safer than helicopters. They will have backup systems, which we call redundancy in aerospace. So if something goes wrong, we will have a backup to ensure that we do not crash, simply put. So where could we see these electrical vertical takeoff and landing vehicles? Well, the most convenient one is to fly over traffic, otherwise called flying taxis. This, for one, reduces the amount of cars in the high traffic areas by having a flying taxi to go over them instead. We could also see them in emergency services like ambulances or rescue missions. And thirdly, to transport workers or cargo for construction projects or otherwise. Okay. So before we move on, let's just have a look at some of the pros and cons of electric aircrafts in the future. So like I said, they will not need fossil fuels, and they will not produce much CO2 in the future. Secondly, we could reduce our commute time. So if we were going to go from an airport to another part of the city, it would take much quicker than it would if you were going to go in a normal taxi. We may see these electrical vertical takeoff and landings this year, and they're expected to be normalized before the end of the decade. And then batteries, although they're heavy now, they are getting better and they can store more charge for a lighter weight. However, the technology is still developing, so we are working really hard to push this forward. And like I said, it needs a lot of charge, and we can't charge it midair, so this is not going to be suitable for a long-haul flight. And then we're going to need to find new charging stations and areas so we can land these vehicles. Okay, so I think I'll take you on to Maddie now.
Okay, so the next couple of slides are going to be based on hydrogen power. So you might have heard this in the news, how there's lots of new sustainable goals to get hydrogen electric hybrids out there. So I'm just going to go into a bit more how they kind of work and are they feasible. So we're going to start with what actually is hydrogen. So hydrogen is the very first element on the periodic table, and it is the most abundant element in the universe. It is the fuel of stars. So every star is made of hydrogen, and then they all collide together to make every other element basically. And before helium balloons, hydrogen was actually used because it's so small and light. It only has 1 electron and 1 proton and 1 neutron, if anyone is into chemistry. So it is the very smallest element, and it's basically just everywhere. One of the key factors which is important in the propulsion part of this is that hydrogen is obviously a key ingredient in water. So it bonds with that oxygen to make H2O. As you can see on the left, the hydrogens are much smaller than an oxygen particle. I think oxygen is number 10 on the periodic table from memory. But yeah, this bonding with oxygen is going to be key in part of our fuel cell technology, which we have some projects here in GKN, but Airbus also has some leading projects to get these working. So we're going to look at how we can now use that water in a fuel cell aircraft. So, as we said before, renewable energy can be used to create electricity, and then we can use that electricity to split that water atom up into the hydrogen and oxygen through a process called electrolysis. I'm not sure if anyone's done this in their chemistry lessons yet. It's basically using electricity to split the positive and negative parts of the atom. So then when you've got the hydrogen, it's made really, really, really cold, so it turns to a liquid. So it's like how the boiling point of water is 100 degrees. That's when it turns from liquid to air. But for hydrogen, that's at negative 253 degrees, which is mega, mega, mega cold. So you keep it really, really, really cold, and then on the airplane, it still needs to stay cold. So there needs to be lots of systems involved for that. And then the fuel cells can convert this hydrogen back to electricity by fusing it again with the oxygen. And the only byproduct of that is water. And then the energy created can drive those motors and propellers and all of that. So it's basically the process of splitting a water atom and then putting it back together on the plane. Obviously, there's going to be some downsides with this, as to keep something at negative 250 degrees Celsius is kind of hard. It's a lot of work, and there's lots of different things which need to be considered, like how are you going to move it around so cold? How are we going to keep it cold? So those kinds of issues is actually what I do in work. I'm currently in the cryogenic team here. So it's exciting things, but there are going to be lots of challenges. So again, there's another pros and cons list of these hydrogen fuel cells. So yes, there's no reliance on fossil fuels, and you don't need to recharge in the air because you can just take your water and split it and put it back together. As I said, the only byproducts are those water, heat, and electricity. So there's no emissions from that, no CO2 made. And I think the most realistic is this: it's going to be made into a hybrid plane. So like how you have hybrid cars, which are both electricity and petrol, it might be a hybrid electric. So the power made from the hydrogen goes into a battery, if that makes sense. But it's also very developing and won't be here for quite a while. So it may not be ready until 2050. So recently our emission goals were pushed back a little bit because the technology is still developing and there's other options which everyone's looking into. So it is a bit slow. The storage can also be dangerous. So with those low temperatures and things, if you quickly heat it up, hydrogen expands loads. So there's issues with, could it explode? Obviously, there'll be loads of safety measures involved, but there are steps which need to be taken to certify that. So there's lots of work behind the scenes here in GKN as well. And it might not be as efficient as a standard battery. So the fuel cells which put it back together and create that electricity again aren't quite as good as just taking a battery with you. So there's lots of kind of compromises which need to be made when looking into hydrogen propulsion. But I think it's definitely an option for the future for those kind of mid-range flights. I'll hand you back over to Jen now.
Yep, so I'm here to talk about SAF. So, aviation biofuel is a type of fuel made from plants and other natural materials. It's different from fossil fuels because imagine using plants that grow above the ground instead of oil from deep below that take millions of years to form and you need to dig for it. So this fuel can be mixed with traditional jet fuel, and this is what's called sustainable aviation fuel. or SAF. So what are biofuels actually made from? They can be from oil crops, like from soybeans, sunflowers, avocado, the normal oil you use for cooking, corn, sugarcane, algae, and from the carbon cycle you can see next to it, it's a really short-term balance cycle. So we're releasing CO2 and taking it back in very quickly, as opposed to fossil fuels, which I said takes millions of years and is a finite resource. So the pros are, of course, it's renewable. We can regrow crops. We cannot make fossil fuels as quick as we're using them. There is cleaner air. So as I said, by airports, the air is really dirty, but using biofuels means cleaner air from flight. And there is a big reduction in CO2. However, we are still developing SAF, so the cost of it is actually 3 times the amount of jet fuel. And this is because it's really hard to scale it up. And the land we're using is currently for growing crops that we need to eat. So there's a lot of competition with food crops. How do we convince them that we need to grow biofuel? So from 2025, the government has made us use at least 2% of SAF in all aviation fuel from the UK, and this is going to keep going up. So we do need to figure out how to use up our land better. Oh, quick question. How much SAF in fuel mix does Airbus want to use by 2030? Is it A, 100%, B, 5%, C, 50%, or D, 30%? We're getting a real big mix of answers. With B, D, and C. Yep. Could we get the answers, Maddie? Yep, it's D, 30%.
Okay, so now I'm going to take you through some of the projects that we're doing here and some of the projects that I'm doing as well in my team. So we'll start off. So aluminium, as Maddie said, is used the most in aircrafts, and a big challenge is recycling it. Not actually recycling it in the sense of you recycle it at home, because we actually do recycle our aluminium at the moment, and it goes down into our Coke cans, our Pepsi cans, but that it isn't valuable to just keep recycling material down to Coke cans. We want to recycle it back to the aluminium that we use in aircraft. So at the moment, from our processes, in the bottom right, we have what you call a billet, which is like a big block that we need to machine into our parts. And when we machine this billet, it will produce swarf, which we can see in the bottom left. And so the swarf is like little chunks of metal. And what we need to do is squash it down into these bricks and then melt it back into the billet. Now, at the moment, the swarf isn't well separated, and it can have a lot of contamination in it, so we cannot allow it to be used back in another part. However, if we effectively separate and segregate and get rid of all the contamination, then the aluminium might be still strong enough to be put back into an aircraft part. And so at the top right here, you can see what we call a rib, which is a part that goes into the wing of the plane and goes across it to give it stability. Okay, so composites. So I'm going to do a little demonstration here to teach you what composites are, because it is a complicated material. So what are they? We have two materials which combine together to get an even stronger material than before. And so these two materials are what you'd call a fiber, which is like a long strand here. I've got a piece of spaghetti, I hope you can see. So it's a long strand, and if I bend it, it will break. But if I have multiple of them, they're going to be harder to break. However, the issue with this is that if I drop it, then they're all just going to fall apart. So we also need what we call the matrix, which is just a fancy word for the glue. And so here I've got some, hope you can see that. This is some honey, which we could use as the glue to put our spaghetti together. And so overnight I've done exactly that, and now I've got a nice thick block of spaghetti that is together, and that's not breaking. And so in aerospace, we use stuff called carbon fiber, which if you look on the left, the individual strands themselves are actually going to be thinner than the hairs on your head. And then we use glue on the right. And so if we combine them together and put them in an oven to cure them, which basically solidifies it, we can get some stuff like F1 car parts or parts for aircrafts, and finally, even parts of spacecrafts. And there are many other things, but that's just some examples. Okay, so why are they hard to recycle? Well, if I want to get from this, our composite, back to the spaghetti and the honey, it's going to be hard to pull it apart. It's going to be hard to separate it, right? And so we could melt it like we do with metals. However, if I try to melt a composite, due to the nature of it, it will just burn, and we can't do that. So there are engineers that have figured out ways to separate it, but they're very special machines and they cost a lot of money. However, we are working on better ways to recycle them, and as part of my project, we are finding out how we can separate the material and reuse it again into aerospace parts. So why can't we just recycle all materials? Well, like I said, the aerospace parts are very high specifications, which basically means that they need to be really strong and really trustworthy to be accepted to go on an aircraft. And so this reinforces how safe our aircrafts are, because we cannot allow material that is substandard to go and fly into the air. Okay, so here we have some really cool robot machines that we have in Bristol, and so I'll try and demonstrate, but this is not my area of expertise. So imagine you have a plate here, and we have a big robot arm that would put molten metal onto it, onto a path, and lay it up like you would lay icing on a cake. And so in the bottom left here, you can see a wall has been created by the robot arm, pouring molten metal on it again and again. And so if we do that into a shape, as you can see on the right, we can actually make shapes, and once we machine them down, we've practically made a shape using almost all the material that we've used. And so that is really efficient, and that will allow us to reduce our costs and reduce our emissions. Okay. And then finally, this is something that we can all do, but this is also what we do in the industry. So imagine you have your oven at home, your light switch at home, and sometimes you might forget to turn it off when you leave the room. And so you're wasting energy because you're not using the light in the room. However, what we've done is that if we have a big sticker next to a light switch or an oven or a machine that just says, when you're not using it, please turn it off. It might seem simple, but it actually does a really effective job at telling people to turn stuff off and save energy. So when we implemented it last year, we actually saved nearly 30,000 kilograms of CO2 per year. And that amount of energy, you could drive your car around the world 4 times. So that shows that something that's just small, like putting stickers next to machines and stuff, can actually make a massive difference.
Cool, thank you very much, James. So we've got a little activity to talk through now to get you guys kind of involved as a little bit of a competition as well. So I'll quickly introduce this, and then you guys can put any questions you might have in the chat about what we've talked about, or about the industry, or just GKN in general. We can have them come through in the chat and we will address those. But Now we've got a kind of activity about, so if you're an aerospace engineer, what kind of aircraft would you go for? So basically, I want to design a plane. So think about what is the problem. So our problem is we can't keep having planes that create so much CO2. Have a look about what already exists. So we've taught you a little bit about the three main options which you could have. So are you going to have a SAF plane, an electric plane, or hydrogen propulsion? So then you've got to kind of think up the design. Is it going to look like a classic plane, or is it going to be something completely new? And then kind of mind map or brainstorm, and then you can just start creating. So making a drawing or a poster, kind of explaining everything. These are some very, very quick example sketches. So you could have a short range private jet, which looks like a classic plane that you might see in the sky. But I've stated that the engines are going to be powered by SAF. The fuel is going to be stored within the plane, and it's going to be made from recycled materials. Or you could go for something crazy. There's a flying shark on the right. So that's more of a helicopter design, so a double helicopter. Again, short range, but that's going to be electric with batteries stored in the belly of the shark. So these designs can be whatever you want. Go absolutely mental. It's okay. So these are the kind of things which I want you to consider. So kind of what power is it going to use? Who's going to use it? How many people can it carry? Is it going to be a really big plane that can carry like 200 people over to Asia? Or is it going to be a little air taxi that can just take up to 10 people from like inner London to outer London? What is it going to look like? How big is it? And what materials is it going to be made from? So these are like key design things which you must consider, like materials especially. So you can't have it all made of really heavy iron. Is it going to be aluminium or maybe composites like James explained? Where are all the batteries going to be stored? Is it going to be in the back, in the front? You're going to have like a little, well, it depends how you're going to do it, where you're going to store your water or your batteries. How is it going to stay in the air? Is it going to have wings? Or maybe going to look more like a helicopter with propellers? When is it going to be built for? Is it going to be for this year? Is it going to be simple, just a small battery? Is it going to be super futuristic and not for 2050? So if you're going to choose like hydrogen, you know that that's not really ready yet, whereas a battery may be more feasible in the next few years. And again, if it goes wrong, you can start again. Engineers always make small and big changes all the time. As I said before, it is a design cycle. So you can kind of do whatever you'd like. But I'd like you to design your own aircraft. And if you make a poster or a really nice drawing, I'll ask that teachers send them in to the email on the screen, same email that sent out this meeting link. And there will be some prizes for the ones which we think are the best. So get designing, and this is also the time for any questions. So you can either put the questions in the chat, or if you want to speak, that is a-okay. But thank you so much for joining, guys, and I hope you enjoyed it. And yeah, absolutely any questions, just pop them in. You put the list back on the screen. Great question. Yes, I can. Control. And you design the aircraft as a team? Absolutely. Team effort, that's always good. Maybe have a designer or someone thinking just about the materials, just like in real life. Question here, if we don't change how aeroplanes are now, could it affect the future badly? I think the simple answer to that would be yes. So if we continue to just make these fossil fuel aircraft, although they're okay now, the rate of global warming is increasing incredibly. And could be bad if we can't change. It's like, I don't know, it will just slowly get worse. As you might remember from Baker Hughes, they looked at like CO2 collection and storage, but there's like bad. I don't know if you ever need to say, James. It would just be bad for global warming.
Yeah, so fortunately, we have targets to make sure that 100% of our projects are related to decarbonisation. So every single project that we are doing from 2025 is going to help reduce our carbon footprint. So you are right, if we don't change how airplanes are now, it can affect the future, but we need a collective effort from everyone around the world to just reduce our impact so we can save the planet, essentially.
Thank you. As we're coming up to the end of the session now, I'd like to thank you all again for joining, and the recording will be sent out kind of as soon as possible. If there are any more questions, feel free to send them through, and I'm very excited to see all these designs.